we have seen that in one-way ANOVA, if your null hypothesis is rejected, we can conclude that there is enough evidence of the alternative hypothesis or the research hypothesis, and we can conclude that not all the means are the same. But we cannot conclude that all the means are different. Which pairs of means are different? In order to know that, we need to perform a post hoc test, which is known as Cohen's d test. So in this class, we will take a look at some assumptions of ANOVA. Like, for example, the independent samples, well modeled by a normal distribution, variance of group same. Like, these assumptions are there in ANOVA. Now, if these assumptions are violated, then we use Kruskal-Wallis test. Here it is given, the Kruskal-Wallis test. You can see that there are 4 groups: no education, school education, vocational education, degree education. So 4 groups are there. And if you have a look at the standard deviation, then the degree has group, the 4th group has a very high standard deviation, which is not even closer to the other groups, non-school and vocation. So in this type of cases, we cannot perform ANOVA. Rather, we need to perform Kruskal-Wallis test. But in most of the cases, we have seen that even if you perform ANOVA, the Kruskal-Wallis test and ANOVA will give you the same result. But this is the standard procedure, Kruskal-Wallis test. So we need to conduct Kruskal-Wallis test. Now, the main thing that we will discuss today, we will focus only on this part, that is known as two-way ANOVA. Earlier we have discussed on one-way ANOVA, but here we will discuss on two-way ANOVA. Here, in one-way ANOVA, we have seen that there were one independent variables. In case of two-way ANOVA, there will be 2 independent variables. In this particular example, there are 2 independent variables. One is gender, boys and girls, and another is age group, that is 10 years old, 11 years old, and 12 years old. And the scores obtained by the boys of 10 years old, girls of 10 years old, boys of 11 years old, girls of 11 years old, boys of 12 years old, and girls of 12 years old are provided. So what will be our hypothesis? Our hypothesis will be, first, the null hypothesis, gender will have no significant effect on student score. And the alternative hypothesis or research hypothesis, corresponding alternative hypothesis or research hypothesis will be, gender will have a significant effect on student score. In case of the second thing is, age will have no significant effect on student score. And then the corresponding alternative or research hypothesis will be, age will have significant effect on student score. Then the third case, the null hypothesis is, gender and age interaction will have no significant effect on student score. And your corresponding alternative or research hypothesis will be, gender and age interaction will have significant effect on student score. Now, one thing is to be noticed that these three pair of hypotheses belong to two-way ANOVA only. These hypotheses, if suppose there were only, if there be only one particular independent variable, for example gender, or if there is only one age group, then what will happen? The problem will be converted into a one-way ANOVA problem if there is only one independent variable. If suppose gender is there excluding age group, or if suppose age group is there excluding the gender. Okay, but here it is not like that. Here when you are saying that gender will have no significant effect on student score, here provided the age group is there in the problem, or when you are saying that age will have no significant effect on student score, it is given provided the gender is there in the problem. So the entire set, this these actually belong to two-way ANOVA, not one-way ANOVA. So why I'm saying this, that I'm coming to the next slide. I will discuss this later on. So first consider, suppose this is a one-way ANOVA, then what will happen? Suppose you are not considering the boys, the gender at all. Okay, there is no gender in the problem is given. Only 10-year-old, 11-year-olds and 12-year-olds students are there. So how can you formulate the one-way ANOVA problem? What will be the answer of that one-way ANOVA? So first you will be calculating, you will have to calculate the total sum of square is equal to 200. I have previously shown you that how to calculate the total sum of square. You will calculate the grand mean, which is 9 here, and you will subtract each and every element of this matrix from 9, then you will make it square and you will sum it up. Then you will be getting some total sum of square, which is 200. Now you need to calculate sum of square between. Sum of square between means here the grand mean is 9, so you should subtract 6.5 minus 9 whole square plus 8.5 minus 9 whole square plus 12 minus 9 whole square, and this will, you will do 6.5 minus 9 whole square, this will be doing for 6 times. 8 minus 5 minus 9 whole square, this we will be doing for 6 times, and 12 minus 9 whole square, this you will be also doing for 6 times. So ultimately you will be ending up to have sum of square between is equal to 93, and your degrees of freedom will be obviously 2. Why? Because there are 3 age groups, so your degrees of freedom will be 3 minus 1, 2. Now you need to calculate sum of square within. How to calculate it? You have already calculated the mean of each group, so your so you subtract each and every element of this group from this mean. 6.5 minus 4 whole square plus 6 minus 6.5 whole square, like this. Then for the second group you need to subtract each and every element of the second group from the mean of the second group, like 8.5 minus 6 whole square, 8.5 minus 6 whole square, 8.5 minus 9 whole square, like that. So the same thing you need to perform also for the third group, and your sum of square within will come out to be it will be 107. And what will be your degrees of freedom? Your degrees of freedom will be 15. Why? Because each and every group there are 6 elements. So the degrees of freedom for each group will be 5. So you are having 3 groups. So 3 into 5, your degrees of freedom will be 15. Now you need to calculate the F statistic, which is nothing but the ratio of two chi-square distribution or variance, which are also known as mean square. So which is given by sum of square divided by the degrees of freedom. So sum of square between divided by 2, okay, and here sum of square within divided by 15, and you will be getting this value. Okay, obviously sum of square between you need to put it in the denominator, because in this way F distribution has been determined. Okay, so you will be getting the value of 6.518. Okay, so now based on the F value, you can calculate, the software will give you the value of P. P means the probability of this statistic at least or as extreme as this statistic from the sample you will be getting. What is that probability? So that probability will be given by the P value. Okay, so software can easily calculate the P value. Why? Because it knows the F distribution for these particular degrees of freedom of 2, 15. So it will give you the P value. Now you will need to compare it with the significance level. Okay, if your P value is less than your significance level, then you can reject your null hypothesis. Okay, so this is what you will perform in case of a one-way ANOVA. Okay, now the same thing in case of gender wise also, the same thing will happen. What will happen here? The total sum of square will be the same like the before. 200 will be the totals, sum of square total, and sum of square total will not change for one-way ANOVA and as well as for two-way ANOVA. Total sum of square for the matrix will be same for all the time. Okay, then you need to calculate the sum of square between. The same procedure you will be following. It will come out to be 32, and the degrees of freedom is 1 because you have only 2 genders. So degrees of freedom will be 2 minus 1 is equal to. Sum of square within, you will follow the same procedure to calculate sum of square within, just like age wise. It will be 168, and your degrees of freedom will be 16. Why 16? Because each group is having 8 degrees of freedom. There are 9 elements, so 9 minus 1, 8 degrees of freedom. So for 2 groups, you are having 2 into 8, 16 degrees of freedom. Then again, you will calculate the F value. Based on the F value, software will generate you the P value, and based on your significance level, you will compare it with the P value, and you will take your decision whether to reject your null hypothesis or you will retain your null null hypothesis. So this is the case of one-way ANOVA. Now in case of two-way ANOVA, there are three pair of hypotheses are there. So if you want to test this hypothesis, what you need to do, you know that in ANOVA we basically take the ratio of the sum of square between by sum of square within, obviously taking into account the degrees of freedom. We calculate the F statistic. So we need to know the sum of square between for the gender and the degrees of freedom for the gender as well. Okay. So here, what will be the gender sum of square? It is sum of square, it is given sum of square between. Okay. So in case of sum of square between, it's just like this thing, okay, 32, and the degrees of freedom is 1. Okay. So it is just like the same calculation here that you have performed for one-way ANOVA. The same thing you will be performing here. Okay. So sum of square between, it will not change in case of two-way ANOVA, because the same things is happening also in case of two-way ANOVA. But when you are calculating, when you are doing the sum of square within calculation, then it will change. Why it will change? Because when you are considering the sum of square within, then that means you are considering the error, then the errors are basically for gender and as well as for age, and that's why you need to take into account gender and age both. So for two-way ANOVA, here you are having 6 groups, 1, 2, 3, 4, 5, 6. You are having 6 groups. So you need to calculate the sum of square within for these 6 groups. Okay. So what will happen in these cases? The degrees of freedom will be 12. Why 12? Because each group is having 3 elements. So the degrees of freedom for each group, it is 2. So for 6 groups, the degrees of freedom will be total of 2 into 6, 12. And also when you will be calculating the sum of square within, then just like the one-way ANOVA, sum of square, in case of the calculation of sum of square within, the average value of the group you will subtract from each of its elements. So here also the same thing. The average value of each group, you have 6 groups when you are considering all the two-way ANOVA. When you are considering age and gender simultaneously, then you need to subtract from 4 minus 6, 6 minus 6, 8 minus 6 whole square, then 6 minus 7 whole square plus 6 minus 7 whole square plus 9 minus 7 whole square, 8 minus 10 whole square, 9 minus 10 whole square, like that. So here all these things are given. So you can see that ultimately if you add all these things, then your total sum of squares within, it will be 68. So you are putting here 68. So you have already calculated the sum of mean square for sum of square gender. In the similar way, you will also calculate the sum of squares for age. Same thing. Here, age wise, your sum of square between it was 93. Your degrees of freedom was 2. So, same thing, sum of squares, degrees of age is 93 and the degrees of freedom is 2. Mean square, then you will calculate 93 by 2, which is nothing but sum of square divided by degrees of freedom, and then you will be determining the F score. And in case of F score, it is sum of square between value 32 and 46.5 divided by sum of square within, which is 5.67, and you will be getting ultimately the F score. So basically the difference you can see why I was saying that gender will have no significant effect on student score. This hypothesis and this hypothesis, they belong to two-way ANOVA, not one-way ANOVA, because in case of one-way ANOVA, the denominator will be different as compared to the two-way ANOVA. But in case of two-way ANOVA, this will be different as compared to the one-way ANOVA. You can see that 5.67. It was not 5.67. It was not 5.67. It was not 5.67 or not. It was not 5.67 because here the sum of square within error you are considering. There you have considered sum of square within, but within gender you have considered, or within age you have considered. But in this case you are considered within gender and age both. That's why sum of square within has actually sum of square within is not there. Only the gender or only age, it is not there. Why? That has also risen because when you are considering the boys, when you are considering the boys or the girls gender wise, so there are obviously the age groups are also there, and or when you are looking at the age groups, the genders are also there. So you need to take this thing in account. Now you can also calculate the F score. You can calculate now you can calculate the sum of square total. You already know that the sum of square total is equal to 200, and the degrees of freedom is obviously the 17, because there are total 1 2 3 4 5 6 into 3 18 elements are there. So 18 minus 1, 17 degrees of freedom, or alternatively 15 plus 2 or 16 plus 1. If you can do that, that also will lead to you 17. So ultimately you have the degrees of freedom of total degrees of freedom 17, and your sum of square is equal to 200. So you can calculate the sum of square for both factors. If you add 32 plus 93 plus 68, and then the resultant, if you subtract from 200, then you will be getting the sum of square for both factors. And similarly, the degrees of freedom also, if the total degrees of freedom 17, so it is 12 plus 2, 14 plus 1, 15. So the sum of square both factors will be 17 minus 52. So now the mean square, it is 7 by 2, which is 3.5, and your F score will be 3.5, which is sum of square between for both the factors divided by sum of square within, for within, which is error for both the factors, that is 5.67. So it is equal to 0.62. Now you will use these scores to calculate or to determine whether to accept the hypothesis, whether to reject the hypothesis or not. So if you look at the first thing, first hypothesis, then you can see that it is 5.64 when you have a degrees of freedom 1, 12. So if you have a look at the F table, then the degrees of freedom 1 and 12, they are intersecting at 4.75. You have value 5.64, which is greater than 4.7. So you can definitely you can reject your null hypothesis, and you can say that gender has sufficient effect on student scores. Then if you have a look at the second hypothesis, you can see that the F statistic is 8.2. So, and your degrees of freedom are 2, 12. So it is 2, 12. It is F is equal to 8.2. So the reject. So here what will happen? Your two degrees of freedom 2 and 12, they are intersecting at 3.89. So this is your 3.89, and you have an F statistic which is 8.2, which is greater than 3.8. So 3.89 greater than, so 8. So in this case also you will reject null hypothesis, and you will be concluding that age will have no significant effect on student score. Now the final and third or the final hypothesis. Your hypothesis was gender will and age interaction, whether the interaction has an effect on student score. Here in this case you can see that your degrees of freedoms are 2, 12 respectively, and your F score is 0.62, 2, 12, it is 3.89. This is the intersection, 3.89, and your F statistics is 0.62, which is less than your test statistic. So you cannot reject your null hypothesis. And here in this case we have measured all the things, or we have compared all the things using the table. But even if you do not have table, there is no problem. The software will provide you p-values, and if you compare your p-value with your significance level alpha, which is generally 0.05, seeing that you can also compare the hypothesis. So in the first case, reject the null hypothesis. In the second case, you also reject the null hypothesis. And in the final case, you fail to reject the null hypothesis. That means you can see that gender might have a significant effect on student score. Age might have a significant effect on student score, but the gender and age interaction may not have significant effect on student score. So this is all about two-way ANOVA, and in the same way you can also perform three-way ANOVA, four-way ANOVA. but you don't need to calculate all these things manually, because software will automatically perform it. You just need to give the instructions that the ANOVA needs to be performed, and you need to uh, give the number of the independent variables, and automatically the software, Minitab or any kind of software, StatGraphics, they can understand that which particular way of ANOVA you are talking about. So in this way, you need to perform this, but you need to interpret all those things. Here the gender is significant, age is significant. These are all independent variables, and the dependent variables in this problem obviously test score. In the interaction effect, you can see that it has not significant effect. Usually up to two-factor interaction is in any kind of experiments, two-factor interaction tests are done, because normally it is found that three-factor interactions effects are not strong enough, and most of the time the null hypothesis is rejected. That means the interaction effect is not significant in most of the cases, particularly if it is three-factor interaction or higher order interaction. But sometimes the two-factor interactions effects are many times they can be many times the two-factor interactions effect can be significant. So that's why two-factor interaction effects are noticed. In the next class, we will discuss about MANOVA, multivariate analysis of variance. In this case, actually, we will focus on the dependent variables rather than the independent variables. We have earlier seen for ANOVA one-way ANOVA for one independent variable, two-way ANOVA for two independent variables. But if you have in all these cases there are one dependent variable, but if you have more than one dependent variables, then how can you do the analysis, or what you would actually like to do, what you would like to perform, that you can calculate from MANOVA. So next class we will MANOVA is not very much required. Usually MANOVA, your engineering experiments, most of the time you perform ANOVA rather than MANOVA. MANOVA is mostly not required, but still we will discuss it. And MANOVA is not also that much easy like ANOVA. It's very much difficult. So the next class we will take a basic view of MANOVA. I'm going to stop the recording.